Alright, welcome back to my programming language devlog, and this may look a little different than last time. That's because I'm using a new editor. So to open it, let's just go end it. Alright, so there have been some major changes since the last devlog. I mean, the compiler is relatively the same, minus a few changes, like for example, everything has to be enclosed in parentheses now. So if you want to do an expression, it would have to go like 5 plus 2, for example, and then you go 5 over 2, whatever you want. Right? Let's just get rid of that. My editor's a little finicky in case you didn't notice, but it's fine. Being a little annoying. A little bit. Alright, so space, buffers, delete. No. Okay, so in the interpreter, we've made major changes, as you can see. So first of all, let's pick this executable, as you can see, quite big. Quite big. Okay, let's go. Go to cd interpreter slash core slash action.exe, and boom, it works now. And this is just some debugging information about it. So the original expression that we used, space D, originally what we did is the original program went like this: 5 plus parentheses. What was it? 6 over 2. So simplify it like that. The original program was like that. And as you can see, add the 5 plus parentheses 6 over 2, which is 3. And you can see that it's 8. So, yeah, basically this is now, let's look at the code actually. Let's go look at our types. Escape, yes, look at our types. We'll go read only. Okay. So, a variable, what the, it's a little bit weird. Just a little bit. So let's just get rid of that. Shouldn't be there. Sorry, it was just a weird formatting thing. Yeah, we can see we have a stack. A very simple stack. This. Oh. Go. Okay. So yeah, as you can see, just a number. This is the type. Oh. I think that's height, right? So everything, perfectly fine. We got a stack structure, which will push data onto it. It's basically an array, right? And then we're going to pop it, which just takes the value off of the stack. Peek, which just takes the top value and returns it, as you can see. So escape, right? Okay. Okay, that's ignore that. So now, utility file, edit anyways. As you can see, this looks very similar to last time until we expand it. And you can see it is much simpler now. Let's just skip over here for vmadd, which just puts it onto the state subtract. It's just pushing a bunch of stuff onto the stack, and now we're checking the case of the stack. But you might be wondering, wait, but doesn't the stack only store data? And you'd be right, that it is stack that the data uses abstraction. Open read only. Alright. So this is much simpler, as you can see. This is just abstraction.it. What we do is we initialize the states, which is what we were pushing with the VM or the sub add, sub subtract, whatever, right? And we have the actual stack, which we use for storing data. Now we have an execute node where we just check the kind, and depending on that, we just call a different function, right? And if it's not one of these, we're just gonna ignore it. So now, if we traverse nodes, we're gonna try all this, right? We're gonna keep going. That's debug information. We don't really need that, but we'll keep it in because why not? And we're gonna ignore an index defect because for some reason it was being very weird, right? It was being very weird. It was giving errors when it shouldn't have. I don't know if that's just a bug, but I digress. Now we just have an example of it. So sub-expression to start, then loading number 5. And we're going to push add onto the stack of states. Now we're going to actually execute the sub-expression. And multiplies, or divide 6 by 2, end it, and the last sub-expression, boom, we're done. We're done. That's the program. And as you can see over here, // abstraction.exe. Boom, we got it. Oh, really? It does that? It's interesting. Didn't know that. Alright, so now let's talk a little more theory. Now, what changed is that this is now a stack-based machine, right? And it directly operates on the AST nodes. So rather than transforming it into some intermediate representation like we did last time, and I mean, as you can see, if the editor lets me escape, this is much simpler. This is literally just so much. It's not simpler. It's just less stuff. Interface, we can just ignore that. That's just a way for getting functions. That's not really doing anything right now. Yeah. So theory, it's a stack. So we just push values directly onto the stack. So for example, hold on. Right, quit. Right, quit. Quit again. Quit. My goodness. Okay. Colon. Quit. Why is it not letting me? Fine. We'll just do it over here. So for example, what we would do if we saw 5 plus 2, or parentheses, right? Five plus 2 divided plus 2 over 2, right? So what that essentially is read as is load 5 onto the stack, start a sub-expression. Now we're going to take load 2 onto the stack. This load 2 onto the stack. This is different from 5 as it is higher on the stack and has a higher priority. Then divide the top value on the stack by 2. Okay, I actually kind of like here. Before we start the sub-expression, push and add onto the stack of states. Right? And then add the now pop the value on the stack, then because the top of the state stack is add it to the new top of the stack. A pop function takes the top of a stack, returns it, and removes it from the stack. For example, let's say you have a stack like this. 5, 1, 2, 3, 4, 5. Now we go stack.pop. Stack.pop. We can now use the value on stack.pop. So, for example, we go print variable outputs 5 stack, which outputs 1, 2, 3, 4. So yeah, the machine is much simpler now. Sure, why not? Write this as dot MD1.